Hello everyone, this is the question asked in GATE 2021 Civil Engineering Set 2. Two identical cube-shaped dice, each with faces numbered 1 to 6, are rolled simultaneously. The probability that an even number is rolled out on each dice is. So, we have been given with two dice and they both are rolled together. Now we have to determine what is the probability that an even number pops up on both the dice. So, in order to solve this problem, let's have a look at the useful data. So, the definition of probability in the most simplest way can be defined as the number of possible outcomes of a particular event divided by the total number of all the outcomes of the same event. For example, if I have a coin and I am flipping a coin to get a head, then my event would correspond me of getting head, and the probability that this event would occur would be given by the possible outcomes that I could get ahead, that is 1, because there is one chance that there is only one head in the coin, and the total number of outcomes would be 2, because when I flip a coin I could get either a head or a tail. So the probability that the event E that I would be getting a head would be 1 by 2. Also, the probability if A and B are two independent events, then the probability that both these events occur simultaneously would be given by the probability of A multiplied by probability of B, provided that these two events are independent. So with this knowledge, let us try to solve the problem. So we have been given with two dice that are rolled simultaneously. So the sample space would look something like this. Now in this sample space, we can see that there are all possible combination of numbers that can occur in both the dice. Now in this sample space, we can clearly mark out the first column, because the first column contains all the values of the second dice that is odd, and the thing that is needed to us is both the dice should have an even number. So I can mark out the first column from this table, which is also the sample space of both the dice. Similarly, I can mark the third and the fifth column because they would correspond to the odd number that would be shown in the second dice. Now, I have marked the odd columns out, and similarly I can mark the odd rows out because this would correspond to the odd numbers that would be shown in the first dice. So first, third and fifth column could be, first, third and fifth row could be marked out. Now this would leave me with a sample space something like this. Now in this sample space, I can clearly see that there are 9 values that corresponds to both the dice showing an even number. So there are 9 values and there are 36 possible outcomes. So the probability that both the dice shows an even number is 1 over 4. Now this problem can be solved by using some shortcut techniques. Let's see how we can solve this problem. So the first technique is about how we are choosing the numbers from the first and the second dice. So we are only concerned about the even numbers that would show up in both the dice. So in dice 1, we are only concerned about 2, 4 and 6. Similarly in dice 2, we are only concerned about 2, 4 and 6 out of the available numbers 1 to 6. Now since both the dice are independent of each other in terms of how the numbers show in both of them, therefore the number of ways in which an even number would show up in both the dice would be given by t1 times t2. So there would be all arrangements from d1 and there would be all arrangements from d2. When they are rolled together, we would have 3 times 3, that is 9 different ways in which an even number could show up. Also, the total number of arrangements that would happen in both the dice with their original sample space would be given by 6 times 6, that is equals to 36. So the probability that an even number shows in both the dice would be given by 9 over 36, which is also equals to 1 by 4. The second way in which we can do is using the probability of independence of events, similarly as we did in the first case, but here we can use the formula directly. Let's see how. So the probability that an even number, so I have a probability that an even number shows in the first dice would be given by 3/6, because there are 3 even numbers out of 6 numbers that a dice can show. So this would give me 1/2. Similarly, the probability that an even number shows in the second dice would also be equal to 3/6. That would give me 1/2. Now the probability that both of these events, E1 and E2, would occur simultaneously, which would correspond to both the dice showing an even number together, would be given by P of E1 times P of E2, which would give me 1/2 times 1/2, which is equals to 1/4. So this is another way in which we can solve the problem. So option D, 1/4, is the right answer. Thank you.